which is with question 23. You see those okay?
Yes.
Okay.
Okay, if it's a positive integer, I believe quantity b would be larger.
Okay. Probably, unless you are 100% certain, I would suggest trying a number. Make it a small number so that you don't have to do a whole lot of testing to determine. So pick a number n that's not prime but small, and that we can figure out its prime factors.
Oh, okay. I read the question completely, totally wrong.
Okay.
How about 9?
Okay. That's fine. I probably would have picked a number that has more than one. No, 9 is fine. 9, I would have picked 4, but it has the same problems that 9 is. But so the number of prime factors it has is 1.
Correct.
Okay, and if you look at 81, that's going to have the same number of prime factors. 1. Okay?
Okay.
They're equal, yes. In other words, for it to pick up additional prime factors, it would actually have to be multiplied by another prime number. Okay, 24, the number of even positive factors of 30 and the number of odd.
Okay, the number of even positive factors would be 1, and odd would be 2, so quantity b. Oh, you know what? I did prime.
Okay. Probably it makes sense to list them is our first step.
Okay.
So list the factors of 30.
Okay, 1 and 30, 2 and 15, 3 and 5.
3 and 10.
Okay. Yeah, 3 and 10, and 6 and 5.
Okay. And then let's just count the number of even and the number of odd. Four evens.
Yes.
4 odds.
So they're the same.
Yeah. So these problems are actually pretty easy. It's just we have to make a list. Well, and the biggest problem with these last 3 problems is understanding what they're asking. That's interpreting what they're asking. It's not hard once we figure that out. But, so number 25.
Quantity A would be larger because quantity B is going to end up being negative. Oh, maybe not.
Okay, that's first inclination you got from substituting 2 n for n, probably.
Right.
Okay. Make sure you try another number.
Yeah, I was going to say this one can't be determined because n could be anything.
Right. In other words, n of 2, this side's bigger. N of 3, this side's bigger.
Okay.
Okay. Okay. Let's see. We want to go to a different subject matter here. What is this called? This is called fractions and decimals. It's asking me to turn off my camera. I'll do that. Hold on. It's probably too big, yes. All right. Hopefully you can read that. Okay, number 1.
Okay, that one is going to be 2/5.
Okay, 12/30 reduces to 2/5. Okay. I'm curious as to whether or not 12/30 would be a proper answer. What do you think? In other words, I haven't seen any instructions that say all fractions need to be reduced to their simplest terms, but I wouldn't doubt that you want to do that.
Okay.
I wouldn't, I don't know. It would be worth knowing whether that is a sufficient answer or not, because if you had a real complex fraction, it might take a while to reduce it, and you wouldn't want to necessarily spend that time. But most of them are going to be of this format, where it's 12/30 and it doesn't take that long to reduce.
So since it's between 30 and 40, do I include 30 and 40?
No, you don't.
Okay.
If they say between, it's definitely not inclusive. In this case, that wouldn't actually make a difference. Oh, yes, it would. Excuse me. Yes. No, because 30 and 40 would, no, neither one of them would be in lowest terms. So it wouldn't make a difference.
Okay. I'm listing them.
Good idea.
And I'd say 3.
Good. Okay. One possible shortcut here would be to recognize that all even numbers are not going to be. So when you go to make your list, you could actually just make this list here. But that's if you notice it. If you don't, no big deal.
Okay.
You got it pretty fast. Okay. So how do I want to write this?
I'm not sure. I'll probably do 168 hours for a week.
Okay. Then that creates perhaps a problem in reducing that fraction.
Okay.
So, in other words, it'd probably take me 30 seconds to reduce that fraction. I'm not sure if your calculator is going to be of assistance with something like that either. In other words, with a regular calculator, a graphing calculator, you could turn that into a decimal and then turn it back into a fraction in 2 steps, and you would have the reduced fraction.
Okay.
But what I was kind of getting at was, let's write it like this. Maybe that'll help. Instead of as 168 and then having to go backwards to reduce it. Well, seven goes into 98. 14 times. Now 14 over 24 is quite a bit easier to reduce because I can see, usually when I go to reduce stuff, my first step is cut them. If they're both even numbers, I'll cut them in half. And I could see instantly that as soon as I turn one of them into prime, it's reduced, no matter what the other one is. Well, that's not actually true. No, I'm sorry. That's not a true statement. Because if I had 7/14ths, it wouldn't be reduced. But 7/12ths happens to be reduced. So, I don't know. How would you have reduced this with the calculator you're going to have available?
Oh, well, it would have definitely taken me a lot longer than the 7 times 24 because I probably would have just reduced by 2 and then...
Yeah, that's what I would have done too, probably. So, yeah, leaving the bottom factored instead of multiplied together is the secret, I think.
Yeah.
Now, when you see a problem like number 4,
Uh-huh.
know that there has to be a shortcut.
Yeah.
There's no way they're wanting you to use that calculator to multiply it out, although that would not take that long. That would only take about 20 seconds. But again, you're going to get a decimal. And the decimal may or may not be translatable into one of those answers. Notice what one of those answers is. 5/30ths. How often do you see an answer like that?
Not very.
No. So I could almost rule that answer out instantly, but that's not going to help here. I mean,
Should I be reducing?
yes, that's the trick. So we have 1 times 1/2 times 1/3 times 1/4 times 1/5. Now it becomes a far simpler problem to get 1 over 120.
Okay.
Okay. Yeah, because on your calculator, you're going to have to do 5 times 5. You're not even going to be able to say 5 to the 5th. And you're definitely going to have to do that in the denominator. But, it would really, this feature on a calculator is really a nice feature to have for test taking where you can take a decimal and convert it to a fraction. So if you have that kind of calculator available to you, it's going to make a difference.
Yeah, and I'm pretty sure that's not what we're going to have.
I don't think so either. That's almost a feature on graphing calculators. I don't see that feature on very many calculators less than graphing calculators. Which means you have to find a different way to do those problems.
Yeah. Now this one I probably use back solving.
Okay, that's not a bad idea. Before you even go that route, look at the relationships of the numbers. In other words, they're telling you 3/11ths and they want to know 6/11ths. 6/11ths is what compared to 3/11ths?
Smaller.
It's twice, exactly twice. 3/11ths times 2 is 6/11ths. So
So
if
20.
3/11ths of the number is 22, twice that much has to be 44. No calculator needed at all.
Oh, wow. Okay.
Okay? That's the kind of stuff they like to do. In other words, you want to always look for those shortcuts. I guess there's a point of diminishing returns where, if you don't want to spend more time looking for the shortcut than it would take to solve the thing in a normal manner. Trying to figure out what this last answer is there. 7/10. Okay. Can you read that, Angela?
I can.
Okay.
Maybe pick a number.
Good.
40.
Good. You want the number that's the least common denominator. So we'll say Jason started with 40 goldfish.
So then 8 of them would have died.
Okay.
Leaving us with
First week, 8 died. How many are alive?
32. Let's see. 3.
You'll notice that an awful lot of these problems, they don't tell you died or alive. They're all constructed so you have to kind of figure out the other end of it in each case.
Okay, and then 12 more died, leaving us with 20. So the answer would be a half.
Good. And that could be done algebraically also. Just letting x equal the number of goldfish you started with and working through the algebra of it. But even the book says that you shouldn't do it that way. The GRE way is to pick numbers, and they picked 40 also.
Okay. Okay, so 5/8 of 24 would be 15. And it's equal to 15/7 of what number? So multiply both sides by 7.
Okay.
Because 15/7x.
Okay. So we have 105 equals 15x.
Divided by 15 equals 7.
Okay, good. That's just a straight algebra simplification or algebra equation to solve. And when you get something like this, I don't know, there's not much relationship between 5/8 and 15/7. So I immediately stop looking for a shortcut and then just solve it straight away.
Okay.
260. Whoops. Okay.
Okay, solve for A, which would be 3/7, and solve for B, which would be 7/3. So 3/7 divided by 7/3 invert it. It'll be 9/49.
Good.
And of course, my first inclination with, just solve it straight out.
Yeah, I don't see any shortcuts really.
Shortcuts.
And no need for one, because you can tell it's going to solve pretty nicely, pretty quickly.
Right.
Now, whether or not we want to multiply those together or not doesn't matter a whole lot, I don't think. Actually,
And I'm coming up with 7/27.
okay. What did you do at this point?
Um,
Now I see. So that's 7 times 7. This is 7 times 3. You got it faster than me. What'd you do? Did you basically do that?
Pardon me?
Did you basically do that, what I did?
I did.
Okay.
I have just been working on these so much lately that...
Very good. Your arithmetic skills are getting really good, which is very helpful. It's people might not consider that helpful because you have that calculator, but I actually think it's tremendously helpful.
Yeah, I do too.
So, okay. There's a C here. Let me look up what C is. C, on number 10, there is also a C that is x plus 1 over x minus 1.
Okay.
The camera didn't get it.
Okay, it looks like A would be bigger. I believe B would be bigger. If I did that correctly.
Mm-hmm.
And then C. C would end up being negative?
Yes. Yes. The only possible shortcut perhaps may be on B. I would take that and separate it into 2 partial fractions.
Oh, okay.
That would be equal to 1 plus 1 over x, and it's a little easier to recognize instantly that that's got to be bigger.
Okay.
And then on C, if we happen to notice that we're taking a number less than 1 and subtracting 1, the denominator, whatever it is, it's negative. So a positive divided by a negative is going to be negative without even knowing the numbers, and it certainly isn't going to be greater than the positive number.
Okay.
So, those tricks are hardly worth the effort, but
No, some of them are really good.
some of them, yeah. On ones like that, it's probably just easy enough to put it in, do it manually.
Okay, definitely going to need help with this one.
Well, we can't pick numbers, for one thing, because they have given us a specific number. So it's important to recognize that.
Okay.
So we're essentially going to have to do this algebraically. And this is a word problem. So I think that the secret to solving word problems is to always start off with the same first step.
Okay.
Define your variable and what is it. And usually you can look at the last part of the last sentence and it'll tell you directly how many students are enrolled. So let's let S equal number of enrolled students. And you don't necessarily have to spell it out like this, but I think it's an extremely important step. Because once you do this, define your variable, the rest of the thing now you're able to lay out an equation. And that's usually what happens on word problems, is the moment you define that variable and what it is, it becomes a whole lot easier.
Okay.
So let's start trying to write an equation. If 1/12 were absent, how many were present? (11/12) of S
Oh, okay.
represents the number of students that came to school first thing in the morning. 1/5 of those present went on a field trip. So what's my next step?
Okay, so 11/12 of the students were present. So 1/5 of the 11/12 went on a field trip.
So we're going to multiply that. That gives us 11/60 S. So that's how many people went on the field trip, leaving 704 behind. So I can say 49/60, the ones left behind, of S is equal to 704. Now, hold on a second. I made a mistake. No, I didn't. No. Perhaps I took an extra step that wasn't needed. In other words, when we figured out how many students went on the field trip, it probably would have been a little better to do the opposite of the 1/5 and multiplied 4/5 times 11/12 S, and that's going to equal 704. Because that's how many students stayed there. I got to the same place. It's just I think I really needed an extra step my way. In other words, this is another one of those problems where everything they give you, you have to figure out the complement of it. The complement being 1 minus that. If 1/12 of the students were absent, 11/12 of them were there. If 1/5 of those that were there went on the field trip, then 4/5 stayed home or stayed in school. So if we take our 11/12 times 4/5, that gives us the number that stayed there.
Okay, and I came up with
Yeah.
I'm sorry, I came up with 960?
Yes. Now, in terms, you don't need really any special tricks to do that. You can do that on the calculator they give you.
Yeah, I just have to try to figure out how to set them up.
Yeah, I suppose the easiest way to do that is that way. and you get 11/15 S equals 704. Yeah. Okay. 960 is correct. Okay. This is another concept they love. This is at least the second question we've had very similar to this.
Okay, I did the first one on the calculator, and I come up with that it is larger.
Okay. All right. And there's nothing wrong with using the calculator on these. Although, yeah, if you were taking the test, using the calculator is fine. However, I do think it's important to let's talk about the principles here.
Okay.
Because they're liable to structure a question that involves these principles that you wouldn't be able to solve on the calculator.
Okay.
Again, if we take a number between 0 and 1 and we square it, it gets smaller. We take the square root of it, it gets bigger. In other words, it does the opposite of numbers greater than 1. If we square 9, it becomes 81. If we take the square root of 9, it becomes 3. So numbers greater than 1 go the opposite of numbers between 0 and 1. So instantly we recognize that here. I mean, we could without having to use a calculator. And then the third one is a similar principle. If you take the reciprocal of a number between 0 and 1, it gets bigger. If you take the reciprocal of a number greater than 1, it gets smaller. 1/2 is less than 2, but if A is 1/2, then 1 over 1/2 is 2. It gets bigger.
Okay, so can I repeat that to be sure I've got it right here?
Sure.
If I take a number between 0 and 1, and if I take the square root of that, it's going to become larger.
Correct.
If I square it, it's going to become smaller.
Correct.
And if I'm dividing it by 1, then it's going to be larger because we're taking the reciprocal.
Yeah, if you're dividing 1 by that number.
By it, yeah.
Yes, that's correct.
Okay. Mm-hmm. Okay. On this one, can we move the decimals to make them similar?
Yes, because the numbers are the same, except for the decimal, then is all we have to figure out is the decimal. And you'll notice all the answers are 1.001 to 100. So we just have to figure out which way we have to move the decimal.
I'm not sure.
Okay. How would we turn 3456 or 34.56 into 0.3456? What would X be?
We'd move it over to the left to...
So what would that require X to be?
100.
Yes.
100.
100, exactly. So if it was just this part, ignore the 789, we would need 100 in the denominator. Now, what would, in order to turn 7.89 into 78.9, what would X need to be?
Well, let's see, we're going to move it to the right once, so it would be 0.1.
Okay, so in one case, X has to be 100, and in the other case, it has to be 0.1, combining those is 10. And we certainly can do that. In other words, we can turn this into two problems. No, we can't. Excuse me. But we can certainly do it this way. Now, the book suggested a couple of alternatives that are probably worth mentioning. Count up the total decimal points there. There's 4 of them. Count up the total decimal points here. There's 5 of them. In order to go from 4 to 5, you have to divide by 10. In other words, if I went from 1 decimal point to 2 decimal points, I would have to divide by 10. So that's another way to do it that I kind of almost prefer. Because when I know I have 4 decimal points going to 5 decimal points, I can take a simple example like that and go from 1 decimal point to 2 decimal points and figure out what I have to do to accomplish that.
Okay.
Okay? And the other method the book suggested was round them off, make the problem easier. Well, if I round it off, I get 35 times 8 over x equals 0.35 times 80 over x. It doesn't necessarily make it easier for me.
Me either.
Yeah, so it's a decimal point problem, no matter how you look at it. Let's see, this is another one that my camera missed the last. 1/2 is E. So here, let me.
Okay, on this one, do I just need to list everything out?
Yeah, this is a counting problem.
Okay.
You can tell if something's a counting problem probably if there's less than 9 things. In other words, if I gave you, let's talk about that principle for a moment. Okay. If I told you that I had 46 numbers, consecutive numbers that added to 47, that looks like it might be a counting problem. I might start with minus 22, minus 21, minus 20, all the way up to plus 22, plus 23, plus 24. Now, in this particular counting problem, there's too many numbers to actually list them all out. You don't have that much time. And there are some counting problems like that, where they intentionally set it up so that you can't list them all out. So you have to look for a pattern. And if I told you that the sum of these numbers was 47, well, right away you can figure out that the sum of minus 22 through 0 is going to be the same as the sum of 0 through 22. They're going to offset. The last 2 numbers add to 47. There must be 45, 46, 47 numbers in that sequence. Okay? So
Okay.
that's a counting problem, but it's not a counting problem that's meant to, where you actually are to list everything out. Whereas I would say if you're looking at a counting problem where there's less than 10 things to list, then go that route. So, and there still may be some shortcuts here. So what are my possible fractions?
Well, we start with 1, 2, 3 in the numerator. So we have 1/2. And then let's see, we could have 2/2 and then 3/2.
Okay. Doesn't matter which one you change, just be consistent. Don't jump all over the place. Because
Okay.
you won't know if you have them all covered. You know what I'm saying?
Yes.
So 1/2, 2/2,
And 3/2.
3/2.
And then 1/3, 2/3, and 3/3. And then 1/4, 2/4, and 3/4.
Okay. We want the product of all of those. So we certainly don't want to do that on the calculator. We want to cancel first, right?
Yes.
And you're left with 1 in the numerator and 3 4s in the denominator.
64.
And that's the answer. Oops. Is that 15? No. There's 15.
I'm not sure.
Okay, well, let's take a number.
Well, we can pick 1,000.
That's what I would have picked also. So if he was supposed to multiply this by 1,000 and he divided it by 1,000 instead, what did he get?
1.
What should he have gotten?
He should have gotten 1 million.
So that's what you have to multiply 1 by. It's basically the 3 zeros plus the 3 zeros.
Okay. That makes sense.
Yeah. Okay.
My guess is there's a quick way to do this, but I would end up just calculating it.
That's fine. Notice that the associative property is in play here. In other words, in either case, we have 5 times 47 divided by 13, same as 47 times 5 divided by 13.
Ah, okay.
Okay? Again, if you know it's a 15-second calculator problem, I'm not sure. It might take 20 seconds to see that connection the other way.
As long as you can see the connection, though, I think that's quick.
Well, I do too, and you should kind of, it would probably be helpful to you if you get into a pattern of looking for those shortcuts. Just don't spend too much time looking for them.
Okay. Quantity B would be greater.
Okay, you just did it straight
Yeah.
manually, and you did that
Well,
manually without a calculator?
Yeah, without a calculator, yes.
Okay, yeah, well, that's good. 18.
Let me see, 15, 1 over 15 inverted. Quantity A.
Good. I have to actually go to the next page here. And 19.
Once again, I know this one should be quick, and I'm not getting it quickly.
Okay, well, how are we going to figure out how many packages she needs to buy? Take the amount of chicken, and if it's useful to use the units, do it. Divide by 3/4 pounds per package. And that number is 32 thirds, which is 10 2/3. And to figure out whether we got this correct or not, make sure the units cancel. In other words, we need to end up with packages. And if you divide by 3/4, you flip both the number and the units so that the pounds cancel and you end up with packages. If I made a mistake and decided to multiply, notice that I don't get packages. I get pounds squared over packages.
Ah, okay.
So by using your units, you can kind of verify whether you're doing it right. You know it's either a multiplication or a division, and it can be helpful to use the units. I'll make that just a little bit larger. Oops. Okay, didn't need it to be that large, but there, perfect. This is an interesting question merely from the fact that we've never seen anything like this.
No, we haven't. So, yeah, we're just 1 unit away from a whole on all of them.
Well, let's take the basic premise of which is bigger, A over B or A plus 1 over B plus 1?
A plus 1 over B plus 1.
Right. In other words, 11/12 compared is smaller than 12/13, definitely smaller than 13/14, which is definitely smaller than 14/15. So, has to be B, because when they say or, in other words, if this was 12/11 or 13/14, and we want to know which is bigger, quantity A is going to be, because we get to choose either of those two numbers. Now, I don't know what it would have meant if they'd have said and. I guess we would have had to add those two numbers together and compare it with this. But when they say or, we're allowed to pick either one.
Okay.
So
And then this one,
how does quantity A read?
well, quantity A would be 3/4 plus 4/3.
And quantity B?
Would be 1/2 divided by 2/3 and plus 2/3 divided by 1/2.
Okay. We may have to do this math. We may not. This looks awfully close to 2. Let's see what this is. Let's see. This term here is what?
Let's see. 25/12.
Okay. Let's not do it that way.
Okay.
In other words, did you add these two and to get 25/12?
You know what,
In other words,
yes,
this may not be a calculator problem. And
yeah, no, I did.
yeah, it's better to leave that alone for just a moment, because we may notice something really quickly.
Okay.
As soon as we do this term here, what is that term equal to?
3/4.
Aha.
So yes.
What are we betting this term is going to equal? 4/3. Almost for sure. The moment before I even do the math, I know it's going to equal 4/3. In other words, they don't want you, what they're looking for here is not to add these two together immediately. It's to leave them in what you may call a factored format. It's not factored because we're not talking of a product, but it's very similar when you have stuff that's factored. It's better off left factored than it is multiplied together frequently.
Okay.
The same case here. Let's not do this math until we have to, because we may notice something immediately when we do this side over here.
Quantity A would be larger.
Good. 23.
Um, 1, 2, 3, 4. So the quantity A would be larger.
Good. This is not testing your math, but testing that 4 negatives multiplied together equal a positive, 3 negatives equal a negative.
Okay, quantity A would be larger. Quantity B,
Good. Without doing the math, correct?
yes, because that's the one you just explained to me.
Yep. Square root's 154. Need to look in my book to see what the next session. Let's see. Percents is the next one. 277. That's the next section. Would you like to stop, or you want to answer a few questions from percents?
We can go ahead and stop.
Okay. Yeah, we made good progress today. Those we got through those questions fast. So.
And thank you. I took a practice test and did a lot better than I had expected to because of the tips that you've given me.
Good. Very good.
So thank you.
You're welcome. Okay, let's see. You have a session Wednesday, right?
Yes.
Wednesday and Thursday?
Yes, Wednesday and Thursday.
Okay, I'll talk to you then.
Okay, thank you.
All right, Angela. Bye-bye.
All right, bye-bye.